So what if I throw this system at you? This system has 3 equations, 3 variables, and I ask you to solve this. And if I really wanted to, I could make an even bigger one. I could give you 10 equations and 10 variables or something, and ask you how to solve that. Well, in some sense, it's possible I can solve this. And using the methods we have currently, it's technically possible. You could sit and try to do elimination on this. You have to do it multiple times, or maybe substitute some variables or something. And eventually, you can probably get it to work, but it's probably going to be kind of a painful experience in general to solve systems that are this big or bigger using the methods that we have now. It's probably just not going to be very fun. And so I don't want you guys to do that. And I never want to have to do it. In fact, I never do. So we want a better method. Solving this is currently a pain. The reason it is a pain is if you try to do this, it's just kind of hard to keep track of all the information in it. I add these 2 equations together, I get some new equation, and I have to keep track of. That's some equation with 2 variables maybe, so then I have to add that one to another one of these, and it just gets complicated. There's equations all over the place. So it's just not a good thing. So we want a way to sort of strip this down and organize the information in a convenient way. We want to organize the information in this system and solving it in some really convenient manner that'll make it easier for us to solve. Because all that's really making this difficult to solve is that it's hard to keep track of everything to do all the work. So we don't need this specific system. This is just a random example I made up. Although, if you're feeling adventurous, try to solve that system. And then maybe you'll be convinced that we need better tools to solve systems. And so the tool that we're going to use is called a matrix. So I'll tell you what a matrix is. And this will be a really non-enlightening definition, but then we'll see a bunch of examples and we'll get some more vocabulary and it'll be better. So for now, a matrix is just an array of numbers. It's a rectangular array. Of numbers. So all these words really mean is that a matrix is going to be like a box, and I'm going to put numbers. It's going to be a box that I fill with numbers. Okay, so let me show you some examples of what we'll call matrices. Here's a bunch of examples of matrices. Here's a matrix with the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 inside of it. Here's another one. Got 1, 0, negative 2, 3, 2, 1 inside of it. And maybe here's another one. Here's another matrix. 1, negative 4, 0, and 3 inside of it. And I could keep going, just draw a bunch of random examples up here. The idea is that I have a rectangular box that I'm indicating with these brackets. So I have these rectangular brackets that I'm going to fill with numbers, and I'm just going to make sure that I put the numbers in rows and columns so they're lined up. That's a matrix. Okay. So for now, this is not helpful. This is just getting us introduced to what these things are going to look like. And then matrices have rows. I'll write this down a little bit more. Like I said, matrices have rows and columns. Okay, matrices have rows and columns, and I don't know, probably color isn't going to show very well in here, but I'll announce what we're doing here. Rows are horizontal. Rows are horizontal, so for example, this is a row of that matrix. This 1, 2, 3 is one of the rows of that matrix. And columns, on the other hand, are the vertical things. They go up and down. So here's a column. 0, 2 is one of the columns of this matrix. Okay. So again, I don't think the colors show up super well on the camera, but point that out. Rows are horizontal from side to side. Columns are up vertical, they go up and down. So I'm going to use the word row and column all the time when we talk about matrices. That's what they mean. And so if we count, this matrix has 3 rows, 3 columns. This one has 2 rows and 3 columns. And this one has 4 rows, but only 1 column. Sometimes they'll just have 1 column, or it could have 1 row. Those will be some special kinds of matrices that we'll talk about later. There we go. So here's some basic vocabulary about matrices so far. It's idea of rows and columns. So I will use these words all the time. So it's good to get comfortable with what they mean. Matrix is just a rectangular array of numbers. We're going to write them this kind of way. Okay. Now, let's talk a little bit about where this is going to come into play with a system of equations. So why are we going to have matrices? And on Monday, we're going to practice doing operations on matrices. Okay. So today, let's see. So we're going to go. If I give you a system, the idea is that I want to get a matrix. So it turns out if I give you a system of equations, I can find a matrix for that system. And I'll show you what I mean. Let me give you a system of equations. We'll do maybe a smaller one here. Basically by example here. So here's a system of equations. We'll start with a system of 2 equations just to sort of illustrate, and then we'll do another example, bigger system. System of 2 equations. 2x plus 3y equals -1 and -x plus 4y equals 0. And turns out there's a way to get a matrix out of this, and I'm going to show you how that works. So to get a matrix, we're going to get a matrix with going to have a column for each variable. And the equal sign, and to the right of the equal sign. So I'm going to have a column for each variable plus an extra column for what's to the right of the equal sign. So remember when we were solving systems of equations by the elimination method, we wanted to make sure the variables in our equations were lined up. And this is sort of why, actually, is when I go to a matrix, if I've already lined up the matrices, then you kind of see that the variables kind of give you columns, right? The x's are lined up here, the y's are lined up here, and to the right of the equal sign is lined up over here. So they're kind of lined up in columns for us already. So those are going to give us the columns of the matrix, and then I'm going to have a row for each equation. A row for each equation. So each row will correspond to an equation. Okay. So to be explicit, let me show you how the matrix will go. I have a row for each equation. Since I have 2 equations, I'm going to have 2 rows. And for each column, there's going to be either a variable or to the right of the equal sign. So that gives me 1, 2, 3 columns. So I'm looking at 2 rows and 3 columns. And to fill them in, all I'm going to do is read off the coefficients. Just going to read off the numbers from the equation. So like my first row is just going to be 2, 3, -. And my second row will be, this is -1, 4, and 0. Okay. So here's my matrix for this system. 2, 3, -1, -1, 4, 0. we just read off the numbers from the equation once we have all the variables and such lined up. Okay. Okay. So this is something you'll want to practice. You want to be good at doing this because you'll kind of have to do it all the time to do these problems. So I give you the system, write down the matrix. So maybe I'll do another quick example here with a bigger system. It'll work the same kind of way. And then we'll probably be about out of time after that. I'll just give you a quick preview. So again, here's another system. I'll give you a bigger one. How about 2x minus y plus 3z, 0. X minus y minus z, 1. And 3x plus 5y plus 4z equals 3. So here's a system with 3 equations, 3 variables. Let's go ahead and write down the matrix for this guy. Okay. So again, I have 3 equations, so I'm looking at 3 rows. And I have 3 variables, plus I have this over here to the right of the equal sign, so I have 4 columns. So 3 rows and 4 columns. And then to get the rows, I just read off the numbers from my equation. So the first row will be 2, negative 1, 3, 0. 2, negative 1, 3, 0. 1, negative 1, negative 1, negative 1 will be my second row. Just reading off this equation. And then if I read off this equation, it will be 3, 5, negative 4. So here would be my matrix. So if it helps you when you're filling these out or when you're messing with these, you might write like a little x or the y, z or something up here to remind you that this is like the x column. These are all the numbers from the x. This is the y column. All these numbers came from the y's and so forth. Anything to help you remember a little bit. But you don't have to write those up there. I will mention something that I often do, and will pretty much start doing from now on, is to help me remember where the equal sign was. Sometimes I'll draw on this bar. I'll draw this bar in my matrix to sort of separate the stuff that was to the right of the equal sign from the stuff that was with the variables. So just think of this bar as equals. Yeah? I will often write this over here. I'm pretty much going to start doing that from now on, and your book will do this too. So if you're reading in the book, you'll see this. And a lot of people do this. So if you're looking around different sources, you'll find this all over the place. And just so you know the words, this is called an augmented matrix. So whenever I write down a matrix from a system of equations, we just call it an augmented matrix. So if I have this bar here, this is corresponding to the system of equations, I might use the word augmented matrix. So your book will use this word. So that's all that means. And just to be a little fancy too, maybe as a last thing to mention, one more piece of terminology is that this part over here, to the left of the bar, we might call this the coefficient matrix. We might call that the coefficient matrix because these numbers came from the coefficients of the variables. And so we might refer to the stuff to the left of the bar as the coefficient matrix. And this is another piece of terminology that your book uses, and it might pop up as we look at some of this stuff. So, and I might need to use it occasionally. So the whole thing is an augmented matrix. This little piece to the left of the bar is the coefficient matrix. Okay. So it looks like we're about out of time. So on Monday, we'll keep talking about matrices. I'll briefly remind you of some of this stuff, and then we'll move on.